Hey everyone, this is Jordan Manis with our Module 8 and our final interactive lab presentation for the semester. And let's go ahead and get started making kinetic sand. So I have some play sand here, so I would say 10 ounces or so. I have some extra here on the side, maybe about 8 ounces worth. It's an ounce cup, wasn't full all the way. So it's a little bit more than I think what was in the packaged bags in the video that we had to watch. So I'm planning on adding some additional cornstarch. With that being said, I have cornstarch here and our pre-mixed soapy water. And the soapy water is going to help with the elasticity because it'll increase the surface tension of the water. And hopefully we have a better result than we had last week. Just like I said last week, so hopefully we can end the semester on a good note and have a successful experiment. So let's go ahead and we're going to add 2 rounded tablespoons of cornstarch here. We're going to mix that up. And one thing I'm going to do at the end is compare our final product to actual kinetic sand that I have here sitting next to me. That is one of my son's favorite activities to do at the moment. It wouldn't be a day without walking in the door and him saying, "Daddy, go play sand." So if this works, which I'm hopeful that it does, he will have a never-ending supply of kinetic sand, considering I bought a 50-pound bag of play sand. All right, so we are thoroughly mixed here, and we're going to start adding our soapy water a little bit at a time, continuing to mix and test the thickness and elasticity of our sand as we go along. Make sure it's all wet before we add any more. All at the bottom. Add a little bit more. And if it gets too wet, I have, like I said, some extra sand on the side, which I think we are going to have to add. Yep. Just dry this off a little bit. As I'm looking over at the actual kinetic sand to see if it's a similar consistency. I think we're definitely on the wet side. A little bit more in. I'm trying to avoid the issue that we saw in the video where it was just too runny, but I don't think we're going to make a comeback from that at this point without adding a lot more sand. So let's give it a test, see what we got. Yeah, it's definitely way too wet, but it is moldable. Does not do it's more like a wet sand, but we're gonna add the rest of this sand here. see if we can get a little bit to come back, like actual kinetic sand. I suppose another unsuccessful experiment would be a fitting way to end the semester, where I haven't had much success in the actual outcomes of the experiments themselves. Why would I expect it to be any other way at this point? All right, so we have about, I would say, 15 to 16 ounces of sand, and we just got way too much water in here to be used as kinetic sand. But you know, the principles are still there, and we'll talk about those in a few minutes once we get cleaned up. But this is my version of kinetic sand that we are all set with. So in just a second, I'll do a comparison once I get my hands cleaned up. All right, so we're back. I got my hands cleaned up a little bit. Let's do a little quick comparison between the kinetic sand that I've made here and the kinetic sand that I purchased at the store. Off camera, I went back and I added some more cornstarch. I had another tablespoon, and it went back, essentially just negated everything that we had done up to that point with the additional sand. That didn't help. Add the other tablespoon of cornstarch. It's almost like we reverted back to the beginning before we even started. So I went back through the process again and made a little bit more adjustments with adding a little bit more water. And at one point, we had a pretty good consistency, and I was a little upset I didn't record it. But then as soon as I added, maybe another quarter teaspoon of water, it immediately went right back to where we were at the end of the recording last time. So we're almost essentially in the same place. However, this is a little bit more thick consistency, more similar to kinetic sand than what we had, where it was very runny. So let's get into our comparison. So this is store-bought kinetic sand, and as you can see, it's starting to slowly fall apart in my fingers if I give it a little squeeze. We are definitely not. Let's see what we have when we do ours. By the way, what I love most about kinetic sand is how you can just tap it and clean it all up. Of course, as I say that, doesn't work. All right, and then we have our kinetic sand. Same thing. So it starts to do the fall like the store-bought kinetic sand. That was a good one. But it's just a little bit more clumpy. A little more wet. Doesn't pick up as nicely. Like I just mentioned, one of my favorite characteristics of kinetic sand. So it's a lot more messy. So anyway, that's a comparison between homemade kinetic sand and store-bought kinetic sand. And after this, I'll get cleaned up and we'll go talk some analysis about the reactions that we just witnessed. All right, welcome back. So we're going to talk now about the reactions and what we observed during our experiment with the kinetic sand. So kinetic sand, it's regular sand and it's been coated with silicon oil. So it's SiO2 is a silica sand molecular formula. And that formulates 98% of the kinetic sand mixture. The remaining 2% is polydimethylsiloxane, and PD and the S is the abbreviated version. So the silicone here doesn't refer to any one specific material, but it does make up a larger group of materials that contain the elements of silicon and oxygen. Silicones are polymers, meaning they're molecules made up of long chains of repeated units. And these silicone oils have unique properties, and they can be liquids that flow freely, or they can flow slowly as semi-solids in the absence of pressure. Now, they also act like rubbery solids under stress. So that's how you get, when we pinch it and it starts to precipitate out of your hands, And that characteristic is called viscoelasticity. So the kinetic sand, the polymer chains within the silicone oil make the sand particles stick together so that you can form any kind of shape, whether it's a ball, a sandcastle, a brick in the case of my son's kinetic sand kit. But no matter what shape you make, that shape will only stay intact for a specific amount of time. It's not a set amount of time, but it's just over time that shape will begin to flatten or to fall apart. That's just the way the kinetic sand works. It doesn't stay in that particular shape in perpetuity. So with that being said, though, the silicone oil coated particles of the sand only allow the sand to stick to itself. And as I had mentioned while we were doing the experiment, one of my favorite things about kinetic sand is that it's easy to clean up. You just use other portions of other clumps of the kinetic sand to clean up all the small pieces that may have fallen out of the box in my case, or onto the floor or onto the table. And I even did it in the video where I used a clump of kinetic sand to pick up the other pieces of the kinetic sand after I let it fall out of my hands. So they'll stick to each other and not to other surfaces. So that's what we observed in our demonstration and in our experiment. And that concludes the kinetic sand piece of today's presentation. But I did want to say thank you, Dr. Capps, for this class and for Chem 125. I learned a lot, so I just want to say thank you, and talk soon. Take care.